So today we're talking about the different forms of a quadratic, and we're going to talk about switching between those forms. All right, because each form has its advantages and disadvantages. So we'll start with standard form. So standard form is y equals ax squared plus bx plus c. That should look familiar. We've been working in that form quite a bit. Now, to find the vertex from standard form, you use this little formula. The x value is negative b over 2a. Okay, and then once you find that x value, to find the y value that goes with it, you just plug in negative b over 2a into the equation that you're given. All right, that's what f of negative b over 2a means. So the y-intercept, if it's in this form, is 0, comma c. All right, and we can prove that if we plug in 0 for x. The only thing that would be left is c, so that's your y-intercept. All right, the quadratic formula is written from this form, and a lot of other quadratic models, when we talk about modeling, that's just when we take a given situation and match a quadratic to it. That's called modeling. A lot of quadratic models, for example, motion under gravity, etc., is written from this form. All right, so those are what we use standard form for. All right, now vertex form is the next form. So that is y equals a times x minus h squared, plus k. All right, now this form is easy because the vertex is just h and k. You'll notice this is very similar to what we had with absolute value functions. All right, it is also easy to describe transformations from vertex form. All right, then the last form is called factored, or what's called intercept form, which is y equals a times x minus p times x minus q. Now this should look familiar because that's what we get when we factor, or that's what we sometimes get when we factor from standard form. All right, so we can go from standard form to factored form, hopefully pretty easy right now because we've practiced it a lot. All right, so what we can get from this form, p and q are the x-intercepts. All right, this form is very handy for understanding where the x-intercepts are. And then finally, the note is the a in each form is the same value from form to form. So when we switch between forms, that a is going to stay in each of the forms. All right, so feel free to pause this video at this point if you want to pause it and write all this stuff down. Now would be the time to do it. All right, so first example, write the following quadratics in the two forms not given. All right, so our first one we have in standard form. So we need to write it in vertex form and then in intercept form. All right, so I'm going to start with vertex form. So in vertex form, there's three things we need to find. We need to find a, we need to find h, and we need to find k. All right, so the a value, we can take straight from the a value from standard form. So the a value is 2. All right, now h is the x value of the vertex. So we talked about on the stuff you just wrote above here on the notes, that to find the x value of the vertex, it's minus b over 2a. Okay, well b is 4, so we'll have minus 4 over 2 times 2. So that's negative 4 over 4. So that's minus 1. So the x value of the vertex is negative 1. Or in other words to say that is h is negative 1. So then we have to find k. So k, to find k, that's the y value of the vertex. So that's going to be f of negative 1. Now I know my function's not written in function notation, but that's okay. I can still write this and understand what I'm doing. All right, so I'm plugging in negative 1 in for x, so I'd have 2 times negative 1 squared plus 4 times negative 1 minus 6. All right, so that's 2 times 1 minus 4 minus 6. So that's just 2 minus 4 minus 6. So 2 minus 4 is negative 2, minus 6 is negative 8. All right, so now we have A, H, and K. It's just a matter of plugging into that formula. So we have 2 times x minus negative 1 squared plus negative 8. So all I did is I substituted, I need another parenthesis there. All I did is I substituted A, H, and K into that general form. All right, now, there are some simplifications that I can make. I don't want to leave minus a negative. That's sloppy. So I'm going to change it to x plus 1 squared. And then instead of plus a minus, I'm just going to write minus 8. So that is the vertex form of this equation. All right, now, the other form is factored form. Okay, so factored form, I'm going to use the factor puzzle, and then I'm going to split the middle term and factor this. All right, so I'm going to start, before I go to my factor puzzle, I'm going to look and see if there's a GCF to take out. All right, notice sometimes there's an A you can take out, sometimes there's not. Okay, sometimes the value of A is 1. So there is a value of 2 that I could factor out, so I am going to factor out a 2. And I'm left with x squared plus 2x minus 3. All right, so then A times C, A is now 1. I'm just factoring what's inside the parentheses. A is 1 times negative 3 is negative 3. What adds to 2? So we need two numbers that multiply to negative 3 and add to 2. Well, that's 3 and negative 1. All right, since we have factored so much, I feel comfortable saying the following kind of shortcut here. Instead of splitting the middle term here inside the parentheses, when there's a 1 out in front of your x squared, now I know there's a 2, but we factored out that 2. So there's a 1 in front of the x squared. When there's a 1 in front of the x squared, okay, I can go directly into my factored form and use the numbers that we got from the factor puzzle. Okay, so it's going to be 2 times x plus 3 times x minus 1. This shortcut only works if the a value is 1 here. Okay, and I'm looking at what's in the parentheses again. Okay, if that was something other than 1 right here, then I would have to split the middle term, group, factor by GCF, and do the whole process that we've done before. Okay, but since you've seen that process multiple times, I feel comfortable telling you that this is an acceptable shortcut. All right, so second problem, same set of directions, just new equation. So notice this equation is in vertex form. So I'm going to need to change to standard form. And also factored form. Now it's important to note that to go straight from vertex to factored form is not a very easy process without first going to standard form. Okay, so I am going to do standard form first. The previous problem I could have done factored form first or vertex form. It doesn't matter there, but here it does matter. Here you're going to want to start by going from vertex to standard, then from standard to factored. Okay, so we have changing to standard. I'm going to need to expand x minus 2 squared. So I'm going to have negative 3 times x minus 2 times x minus 2 plus 3. So now I have to expand x minus 2 times x minus 2. So I'm going to have negative 3 times x squared minus 4x plus 4. Okay, yes, I did take a shortcut. I kind of did some of this in my head. If you have to show all the FOILing steps for it to make sense for you, please do that. And then check and see if you got what I got here. All right, and then I got plus 3. So next I have to multiply, so I have to distribute that negative 3. So it's going to be negative 3x squared minus 12x minus 12. And then I still have that plus 3. Next, I'm going to combine like terms, so negative 3x minus 12x minus 9. And there's the standard form of this equation. All right, so next we have to do factored form. So from factored form, or to get to factored form, excuse me, we're going to use our standard form. We start by taking out a GCF if there is one, and there happens to be one here. It's negative 3. Okay, so now I'm going to factor what's inside of the parentheses. So A times C is 3, adding to 4, so 3 and 1 are those two numbers. And again, I'm going to use the shortcut here because I have a 1 in front of my x squared. So I have negative 3 times x plus 3 times x plus 1. And now we're in factored form. All right, so second example. We want to write y equals 4x squared minus 1 in vertex form. Okay, so in vertex form, we know we need A, H, and K. So A is going to be 4. H is given by the expression negative B over 2A. Now, what is B? We have 4x squared, so that's ax squared, plus bx. There's no bx term. So in that case, our b is 0. So we have minus 0 over 2 times 4. Well, 0 divided by anything is 0. So our h is 0. To find k, we do f of 0, which is 4 times 0 squared minus 1, which is negative 1. All right? So now plugging into vertex form, we get A times x minus h squared minus 1. And that's technically vertex form. Now, what is x minus 0? Okay, x minus 0 is just x. And then if you square the x, you get the exact same equation. So I wrote this example for the reason that when you have no bx term and you're in standard form, okay, that is technically vertex form as well. All right, it's just that the x value of the vertex is 0. Moving on to example 3. The graph of y equals x squared is transformed to attain the graph of g of x equals negative x squared plus 6x minus 7. State the transformations that were applied to f to obtain g. So here's a problem where this form is not very helpful in describing transformations or to see the transformations that go from one function to another. All right, so what we're going to do is take y equals, or g of x, and we're going to write it in vertex form. All right, so we've done this already today. We've seen that a is negative 1, h is negative b over 2a. So b is 6, so we have minus 6 over 2 times a, which a is negative 1. So that's negative 6 over negative 2, which is 3. And then k is g of 3. So all I'm doing is plugging in 3. So I have minus 3 squared plus 6 times 3 minus 7. All right, so notice how when I plug in an x value, I plug it in parentheses. It's very important that you understand that this says minus x squared and that there's an order of operations that is implied here. So a common mistake is to say, oh, well, this is just minus 3 squared. Well, no, that would end up in a negative number. What this is saying is you square x, then take the negative of that value. You could almost see that as like negative 1 times x squared. And exponents could come before multiplication. So that's why we write it this way. All right? So, now, moving on. We have 3 squared, which is 9. So negative 9 plus 18 minus 7. So negative 9 plus 18 is 9, minus 7 is 2. All right, so in vertex form, our function would look like negative 1, but I don't need to write the 1 there. I'm just going to write negative. I'd have x minus 3 squared plus 2. All right, so that is g of x in vertex form. Now to write the transformations. This negative a value produces a reflection across the x-axis. So g is reflected across the x-axis. All right, so I did that negative. Now what does that 3 do? That minus 3 shifts to the right 3 units. Then this plus 2 would be a shift up 2 units. So and shifts up 2 units from f. And now we can name the transformations. Okay, you can see that hardly any of those things come from standard form. It's easily seen when we switch to vertex form. Last example, this example says the function f of x equals x squared plus 2x minus 10 can be written in the form f of x equals a x minus h squared plus k. Find the value of h and k. So this is a straightforward question, but I see a lot of students overthink this question and then mess up how they write their answers. So h is equal to negative, let me use a different color, negative b over 2a. So b is 2, a is 1, so I have negative 2 over 2 times 1, which is negative 2 over 2, which is negative 1. So in my final answer, h is negative 1. Now the mistake I see students make is they think, well, when I plug it into this formula, I know that minus a negative is going to be a positive, so h must be positive 1. No, this is the value of h. Okay? Since this is a minus h, if h is negative, yes, it will look like a plus in the equation, but the value of h is actually negative 1. It's opposite the sign in the equation. All right? Because we straight up found h here, and we're not taking it from the equation, this is the value of h. All right? So if I was to ask you, let's give an equation. Now let's do x minus 3 squared plus 2. If I was to ask you for the value of h and k here, okay, h, if you said h is negative 3, you'd be wrong, because in the general form it's x minus h. So in order for this to stay a minus, this h has to be positive. So h is 3 here and k is 2. Okay, so that's a mistake I see people make, is when they're actually solving for h and using the minus b over 2a, this is your h value. Don't think of it like when you take it from an equation. Alright, so then k is just going to be f of negative 1, which is negative 1 squared plus 2 times negative 1 minus 10. So I have 1 minus 2 minus 10, which is negative 11. And there's my final answer. Well, that concludes the lesson on the forms of a quadratic. If you need help, you know how to reach me, and hope you have a good day.